Hello guys, welcome back. This is Tronic Synergy. We are still testing our 4-bit ALU. So today I just wanted to do for us to check the logic operations in which our IC can do. We are going to do AND, or, not A and not B. Now, doesn't mean that these are the only ones which the IC can do. It can do a whole many of logic operations, like not like A, B. It can do A, not B. It can do A, nor B, B, NAND, things like that. Very many, X, or, yeah. So for today, just wanted to do these four main ones, which are also going to be the ones that we are going to focus on when we are building the 4-bit ALU itself. Now, let's start with A and B. So A and B. So we have to put this code in the selector. So one, okay, I had already put it 1 1 1, then 0. So it's already doing A and B. And remember, for A and B, for it to perform these, both of the inputs have to be high in order for it to give an output. So if I put the least significant bit high, I also have to do the same on the B side. This is A and this is B. I have to do the same on the B side for it to give an output. So this means that this least significant bit is being compared to this this is turning off. This significant bit, they are being compared in an AND logic gate, and since both of them are high, they're going to give an output. Yeah, if I do the same on any bit, like number 2 here, you can see it's giving an output when both of them are high. So that's an AND operation. Just basic, both of them have to be high in order for it to give an output. Yeah. So let's go to an OR operation. OR operation, I have to put 1 0 1 1 1 0 0, then 1, then 1, like that. So already it's doing OR operation. And for OR operation, it's a little bit, it's different. Any of the input can turn on the output. So if I just turn any input high, it's going to turn on the output. Doesn't have to correspond with the B side. Also the B side, if I turn on the same input, nothing going to change because it was already high. So it's either A or B or both of them, they are going to turn on the output. If I turn on the another, like number 2 there, okay, it's bouncing back. If I turn on number 2, you can see it's giving an output. Doesn't really have to correspond with the other side. If I turn on the first one, you can see it's giving an output. So either A or B are going to turn on the output. Yeah. Okay, let's go to A. Let's go to not A. So basically this one is going to invert the value that you have in A. So if A is 1, it's going to be a 0 in the output. If A is 0, it's going to give a 1 in the output. So for us to perform this, we have to put 0 0 0 in our selector, and immediately you can see all of the LEDs are high. So because the input, all of them are low, the output is inverting what A has in the input. So if I turn on the least significant, you can see it's turning off. It's just basically doing the opposite of what I'm doing in the input. You can see it's turning off as I'm going. As I'm turning this on, it's turning this off. So it's just basically inverting what we have. So you can just do any combination that you want. So it's going to be checking the opposite. It's going to invert the opposite that you have in A. Yeah, let's go to not B. So not B, I have to put 0 1 0 1 0, then 1, then 0, then 1 in the selector. Also, it's doing the opposite of what it has in B, just the same. If we turn on the least significant, if we go turning on like that, just basically doing the opposite of what I'm putting in B. So if I just turn that on, if I just turn that on, the middle ones, you can see they are going off in the output because it's inverting what I'm doing in the input. Yeah, that's basically what it's doing. Yeah, so you can do whichever combination that you have. And these are very important. Once we are building the architecture of the 4-bit computer, we are going to understand why these logic operations are the ones that we have chosen and why they are important. We are also the XOR is also important. We are still going to use it Yeah, so that's the logic operations which I wanted to show you guys today. And this not A, not B. This, remember, this is not B. However, I try to manipulate A. It's not going to do anything in the output because we are doing not B. It's only going to respond to the B input. Only we're going to respond in the B input. Nothing is going to change if we manipulate A however we want, like that. You can see. Yeah. So that's what I wanted to show you guys today. If you have any questions, you can still ask. We are moving on well. I'm still to get the 189 chip, which is going to become the RAM of our 4-bit computer. So once I get it, we are still going to go to do some tutorials. I'm going to make the programmer circuit so that we start building our 4-bit computer slowly. So we are still going to learn this one. Yeah. So till we meet next time. Goodbye. If you have any questions, you can still ask. I'm here. I'll be glad to answer you. Yeah.